In this video, I'm going to demonstrate how to factor a quadratic. So a quadratic equation has the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0. The reason I say a is not equal to 0 because if a were 0, I would just have bx plus c, and that's just linear. When a equals 1, we have x squared plus bx plus c equals 0. And I'm going to show you the method that I use to factor these. I call it target product, target sum. It's the method that my Algebra 1 teacher taught me. So the idea here is, we'll start with this one example here. So this is B and this is C. So we want factors of C that sum to B. So we want factors of 1 that add to 2. So my factors of 1 are 1 times 1, right? Because there's no other factors that when I add them to, or sorry, when I multiply them together, I get 1. So, and their sum, 1 plus 1, is 2. So this tells me that I'm going to use 1 and 1. So all I do is I take this quadratic here, and I rewrite it in terms of its factors, x plus 1, x plus 1. And then to solve this, I use the zero product property. That is, if I have two numbers, a and b, and I multiply them, and they're equal to 0, then either a equals 0 or b equals 0. So think about that for a second. There's no two numbers that I can multiply together that are non-zero to get 0. So one of them has to be 0. So we just take the two factors and separately set them equal to 0. So x plus 1 equals 0, and x plus 1 equals 0. Now we can subtract 1 from both sides, and I get x is equal to minus 1. Same thing here. X is equal to negative 1. This tells me that x is equal to negative 1, and this is the solution to this equation. Okay, we're going to do a little bit more tricky of an example. So again, if this is my b here, and this is my c here, I want factors of 12 that add to negative 7. So my factors of 12 are what? 12 and 1, 3 and 4. I could also do negative 3 and negative 4. And their sums, 12 plus 1 is 13. 3 plus 4 is 7. Negative 3 minus 4 is negative 7. And this negative 7 matches our b, so we're going to use negative 3 and negative 4. So again, I just take this and rewrite it in terms of its factors, x minus 3 and x minus 4. And then I separately set these equal to 0. So I have x minus 3 equals 0, and x minus 4 equals 0. So adding 3 to both sides, I get that x is equal to 3. Adding 4 to both sides here, I get that x is equal to 4. So my two solutions to this quadratic equation here are x equals 3 and x equals 4. Both of those satisfy this equation here. Okay, moving on. So when a does not equal 0, we have the full quadratic equation, ax squared plus bx plus c equals 0. Okay, and we're going to factor these by grouping. So to start the process out, it's kind of the same as the target product, target sum method. We're still trying to find factors of something that add to something, but this time we want factors of a times c that add to b. So what do I mean by that? Well, this is my a, this is my b, and this is my c. So I want factors of a times c, that is factors of 3 times 7, so 3 times 7. So I want factors of 21 that add to negative 22. Okay, let's think about factors of 21. Well, I have, let's see, I have 1 and 21. I have 3 and 7, and I have negative 1 and 21 and negative 21, sorry, and negative 3 and negative 7. and their sums, 1 plus 21 is 22, 3 plus 7 is 10, -1 plus -21 is -22, and I can stop here because this is b. b is -22. So rewriting this here. So what I'm going to do is I can't just rewrite this in terms of its factors when we have a not equal to 1. So what I'm going to do is I'm going to let me rewrite this here so I can make it clear what I'm doing. 22x plus 7 equals 0. So I'm going to split this up cleverly here, this 22x. And I'll have 3x squared minus 21x minus 1x plus 7 equals 0. And now I'm just going to, you can verify that -21x minus 1x is -22x. So I did something legal, I split it up. Now I'm going to split this equation right down the middle, and we're going to do what's called grouping. So I'm going to factor just this side here, and I notice that I can factor out a 3x. If I factor out 3x, I'm just left with x from this x squared, 3x squared, and then 21 divided 3 is -7, and then I obviously take out the x. So now I want to make this x plus -1x plus 7. I want to factor something out to get x minus 7. And I notice that it's just off by a sign, so I can factor out a -1. Cool. So now what I can do is I can rewrite this as I take these two factors out front here, 3x minus 1, and I take this factor here, x minus 7 equals 0. And that is my factored form. Okay, so again, I can set these separately equal to 0 by the zero product property. So I'll have 3x minus 1 equals 0 and x minus 7 equals 0. So I have, adding 1 to both sides, 3x equals 1. Divide both sides by 3, x equals 1/3. Over here, I just add 7 to both sides, and I get that x is equal to 7. And these are my two values that satisfy my original quadratic equation. Okay, moving on, we'll do another example of factoring by grouping. So we want our product, if I can spell, product to be 2 times -15. 2 times -15, and that is -30. And we want them to add to 7. So factors of -30. Let's think here. I got 3 and -10. I got -3 and 10. We just saw 2 times -15, -2 and 15, and I can keep listing. And then we'll compute their sum. So 3 minus 10 is -7. -3 plus 10 is 7, and I can stop because this 7 matches my b here. That's what I was looking for, my sum. So that tells me that the factors I need to use are -3 and 10. So I'll rewrite this down here as 2x squared plus 7x minus 15 equals 0. So I'll split this middle term here up into the two factors. So x squared, and then we'll do plus 10x minus 3x minus 15 equals 0. Okay. Again, I'll just split it right down the middle. And I'll try and factor this side first. So I notice that these both have a 2x in them. So I can factor out a 2x, and I get x plus 5. And then here, I notice, well, I'm trying to get x plus 5. So I want to factor something out of this to get x plus 5. Well, if I factor out a -3, this becomes x, and this becomes +5, so I'll factor out a -3. And now I can rewrite the factored form as 2x minus 3 times x plus 5 equals 0. And again, I can separately set these equal to 0. So I have 2x minus 3 equals 0 and x plus 5 equals 0. So adding 3 to both sides, I get that 2x equals 3. Dividing both sides by 2, I get that x is equal to 3/2. And then subtracting 5 from both sides here, I get x is equal to -5. So these are my two values that satisfy the original equation. Okay, and that's kind of all I have to say about factoring quadratics. If you found this helpful, please consider liking and subscribing. Thanks.